Hello, so today we'll be discussing about isomerism in context to organic chemistry. Now, isomerism are of two types, that is structural and stereoisomerism. Now, coming to types of structural isomerism, there are four major types of structural isomerism, that is chain isomerism, position isomerism, functional isomerism, and metamerism. In chain isomerism, these isomerisms have the same molecular formula, but they are different in the order in which the carbon atoms are bonded to each other. For example, now here I have written an example of two compounds. First one is N-butane and the second one is isobutane. Here you can see that the bonding of the carbon atom, the position is basically different. So first it is bonded in a different chain, and in the second example it's bonded via different structure. The second one is position isomerism. In this, they have the same molecular formula, but they are different in the position of the functional group in the C atom, that is the carbon atom. So, for example, one bromobutane or two bromobutane are isomers, but the position of bromine is different. In the first one is in the first position, that is one bromobutane, whereas in the it is in the second position of the chain, that is two bromobutane. Moving to functional isomerism, they have the same molecular formula but they are different in the functional group, like ethanol and dimethyl ether. Ethanol is CH3CH2OH, whereas dimethyl ether is CH3OCH3. Metamerism. This type of isomerism is due to the unequal distribution of carbon atom on either side of the functional group members belong to the same homologous series. For example, again, diethyl ether, that is CH3CH2O, CH2CH3. And then comes methyl propyl ether, that is CH3O, CH2CH2CH3. Here we can see the whole formula is same. We have two CH3s and two CH2s and one O, but it's in a different order. In the first one we have CH3CH2, then we have O, and then CH2CH3. So there are two this side and two on the other side of the functional group. Then we have the methyl propyl ether where we have CH3, then we have O, and then CH2, CH2, CH3. So here we have unequal distribution of the carbon atoms on the sides of the functional group. This is what metamerism actually means. Moving to types of stereoisomers. Stereoisomers are of two types that we had discussed previously also. It's geometrical isomers and optical isomers. Geometrical isomers are basically the isomers in which the ligands are on different relative positions. That, for example, I gave you the cis and the trans isomers come under geometrical isomers. And when it comes to optical isomers, they have the opposite effect on the plane polarized light, and they are non-superimposable mirror images of each other. So they do not possess the plane of symmetry basically. That is it for this discussion.